Hello, we're doing the distributive property today, and as opposed to just showing you some theoretical examples or theoretical applications, formulas, I think it's best to just really jump into it. It makes it a lot easier, a lot more approachable. So basically, the distributive property is when you have a quantity. Quantity is something that's in parentheses, and there's something that's being multiplied outside of that quantity. It can be in front or it can be in the back, but generally you're going to see problems where what you're multiplying by is in front of the quantity. And before I go into it, multiplication is, well, if there's no plus or a minus in between, it automatically means that it's a multiplication. So this reads 4 times the quantity y plus 3, 4 times the quantity y minus 3, n times the quantity n minus 3, and so on and so forth. So when I think about distributing, I think about either like the math marines is what I give as an example to my students in class, but I've also heard that somebody dealing cards is an example of distributing, which I actually kind of like. And that's exactly what you're doing here. The number outside the parenthesis is the dealer, and you have to deal as many times as there are terms inside the parentheses. And what I mean by that is that there's 2 terms in here, so you deal twice. 2 terms deal, 2 terms. If there were 3 terms, then you'd have to deal 3 times, and 4 terms, etc. But most of these problems just deal with, well, not most, all of them deal with dealing with 2 terms. So that's what we're going to do. We're going to take this 4, and I like circling it before I deal. And I'm going to deal into the y, and I'm going to deal into the 3. 4 times y is just 4y. It's not 12, it's not 8, it's 4y. You can't do anything besides just put it together. And 4 times 3 is 12. But be careful here, because a lot of students, they just put 12 without telling me if it was a positive 12 or a negative 12. And 4 times 3 is a positive and 12. And you can't do anything more than that. You can't combine 4y and 12 together. You can't add them. They're not like terms. This has a y and this doesn't have a y. It's like saying, I can't really think of anything clever besides the word yaks, so I'm going to use yaks. This is 4 yaks plus 12 people. 4 yaks plus 12 people is just 4 yaks plus 12 people. It's not 16 yaks, it's not 16, it's just 4 yaks plus 12 people. And that's sometimes very difficult for students to comprehend. But as long as you kind of visualize it as something else, it makes a little bit more sense. So that's all I can do. Done. My distributor here again is 4. As you can see, not always very clever with it, but it's nice to see the very same type of example going on, how you approach it. 4 times y is 4y. 4 times negative 3 is negative, so you put a negative and it's 12. Same thing, they're not like terms. One has a variable, one doesn't, so you can't combine them. This is one term right here, 4y, and this is another term right here, negative 12. And if they don't have exactly the same variable and exactly the same power on the variable, can't do anything. We're going to try something now where the dealer, instead of a number, is a variable, and it throws students off. They get tricked and say, oh, this is difficult. Initially, yes, but if you practice it, it's not too bad. So n times n is not 2n. That would be 2 times n. N times n is n to the power of 2. And then n times negative 3 is negative, and then 3n. And again, these aren't like terms. This has a squared on top, and this doesn't have a squared on top. And people will say, well, this has an n, and this has an n. Yes, but it has n squared. And this just has regular n. It's like, you know, n squared ninjas minus 3 ninjas. No, these are some special type of ninjas. They're the square ninjas versus just, you know, 3 regular ninjas. You can't combine them. Not like terms. Moving on. I'm going to distribute the n twice. Plus, I'm not exactly sure if I'm in camera shot here, so I'll go on this side instead, although it's difficult for me as a left-hander. Negative 4 times y, negative 4y. Negative times a positive is a negative 12. I forgot to circle that first answer too. Negative times a negative is a positive 12. Last but certainly not least, and a little bit more difficult of a problem, I got negative and then in parentheses, or quantity, x minus 3. And somebody says, well, what do you distribute here? There's no number. Well, there is actually. If you don't see a number, it's automatically 1. And in this case, it's not just 1, it's negative 1. So I'm going to distribute negative 1 times x, negative 1x, negative 1 times negative 3, positive 3. There you go. Here's an x-man and 3 regular people. Can't be combined, not like terms. I want to do one more type of example on the distributive property, but I'm going to save that for the next little clipping of sorts. Until then, have a great day.